Hello and welcome back to the Power of BI channel. And in this video series, we are just going through Azure AI 900 exam topics. And this is a continuation of the other topics that we discussed in the previous videos. In this video, I'll be going through fundamentals of computer vision, and we'll be covering Azure services as well as how it works in a theoretical aspect and what it is required for the exam to be attempted. So computer vision is one of the core areas of artificial intelligence, and it focuses on creating solutions that applications see the world and make sense of it. Computer actually process the images either from a live camera feed or digital photographs or videos, and this ability to process image is the key of creating software that can emulate computer vision, and emulate the vision as per the human visual perception. So we'll be going through some of the fundamental principles and techniques about the computer vision, and as well we'll introduce the Azure AI Vision services that developers can use to create wide range of computer vision solution. So before we can explore image processing and other computer vision capabilities, it is useful to consider what an image actually looks like in context of the data. So this is a two-dimensional pixelated grayscale image, and this image is an array of numerical pixel values. 7 by 7 pixel image, which is known as the image resolution. So it actually has the two dimension represent rows and columns with the x and y coordinates as well, and then define a single rectangle of a pixel value as well. In reality, most digital images are multidimensional and consist of three layers known as channels that represent red, green, and blue. The purple, this basically goes through a combination, and if you can see here, this purple represents what do you call it, a combination of red, green, and blue, and the yellow square here is the center that represents the other combination. Um, so so this is basically a filter of array, and it represents the color images, and by defining the three channel of pixel value that create the same square shapes with colors. And if we define a filter, it is defined as one or more arrays of pixel values, which is we can define it as 3 by 3 support or 3 by 3 kernel, and then it is a common way to perform image processing task is to apply filters that modify the pixel value of an image to create a visual effect. A filter is basically defined by one or more arrays of pixel value. So if we get started with the grayscale image, the uh, what we have done is, this is the grayscale image that we have explored previously. We apply filters to the top left of the filter, and each pixel value by corresponding the value in the kernel and details, and then the process is repeated until the filter has been convolved across the entire image. So this is basically the end result. And if we move to another example, to see the effect of filter more clearly, here is an example of the same filter applied. So this is basically a banana picture, and then we have applied a filter that highlights the edges of the object of the image. There are many kinds of filters that you can use to create, like blurring, sharpening, or color inversion, or another effect as well. So the ability to use filter to apply effects on the images is useful in image processing tasks, such as you might perform with image editing software. But this is the goal of computer vision, to extract the actionable insights from the images, which requires the creation of machine learning models, and we establish a recognizing feature based on the large volume of the existing image. This comes up with a convolutional neural network, which is a training, it trains the model, extract the numerical features of the images, as well as it defines a randomly generated values, and then the after progression of the training process, the model predictions are evaluated against known label values, and filter weights are adjusted to improve accuracy. Eventually, the trained banana image classification model uses the filter weight that best extract the features to help identify different kinds of fruits. For example, in an image classification in scenario, the label represent the main subject of image, and I mean to say what is this image of, and you might also train the model with the image of different kind of fruits such as apple, banana, oranges, so that they can be labeled as predicted, and this type of fruit is given an image. So this is basically um, the neural network model that we can train into. And these are the images with known labels, like zero for apple, one for banana, two for oranges. And during this output, the probabilities are compared to the actual class of labor, in the end. But one or more layers of filter is used to extract feature from each images as it is fed through the network, and then that feature map are flattened into a single dimension. And then these feature value are fed into a fully connected neural network. Then the output layer gives a probability value of each possible cases. For example, in this way, it's giving zero point 0.2, zero point 0.5, zero point 0.3 for the all three of the comparison. So convolution model has been core of computer vision uh, for many years, but while they are commonly used to solve image classification problems, they're also basis for more complex computer vision models, um, like object detection, as well as region of interest and all the stuff. So transformers in an AI discipline, another type of neural network architecture, which has enabled the development of sophisticated model for language. Mm, Transformers work by processing huge volume of data and encoding languages represented in a virtual, individual words or phrases, vector-based images as well. There is a simple example. Some words are encoded as a three-dimensional vector and plotted in the 3D space. We've used three dimension because that's easy to visualize. In reality, encoders in transformers network create vectors with many more dimensions, defining complex semantic relationship between tokens based on linear algebraic calculations. I mean, this is more mathematical as well as linear algebra with the matrix as well. And then but the main goal is to provide just a conceptual understanding of how encoding creates a model that encapsulates relationship between entities. The model is trained to use a large volume of images as well as no fixed label, and then the encoder and extract features from image based on the pixel values and combine them with the text embedding created by a language encoder. The Microsoft Florence model is just related to such model, trained with huge volumes of captioned images from internet. It includes both language encoder as well as image encoder. So it's an example of a foundational model, which is pre-trained generic model to do some specific or specialist task. For example, you can use the Florence foundation model to do some image classification, like which category of an image belong to, object detection, locating individual objects within an image, or captioning, generating appropriate description of images, as well as tagging, which is with compiling a list of relevant tags for an image. So what we can do is in Azure AI Vision, it's a service where we can utilize all the image processing as well as the other defined concepts there as well. So there are few services that we can utilize. One is the Azure AI language. The second one is computer vision as well as the translator. It also supports optical character recognition, caption generation, description generation, as well as tagging of the images as well. So this is Azure Vision Studio provides a sophisticated computer vision solution quickly and easily to take advantage of off-the-shelf functionalities of many computer vision scenarios. So this provides multiple things like optical character recognitions, describing an image with caption, to analyze the image, evaluate the objects, and detect as well, and also common objects in an image as well, like skateboard, a person. This prediction also include confidence score as well as it gives a kind of a coordinates as well to detect what whether the image is where the image objects it is being detected. Tagging means that it is based on the content as well as these tags can be associated with the image as metadata that summarizes attributes, and also it gives a specific scenarios or grouping in the way. For example, the tags written for the skateboard or skate holder image was association with the confidence interval of the tags, like sports, a person, a footwear, or skating or skateboarding equipment. These are all the confidence interval that has been given as a tag. You can also train some custom model if um, uh, the built-in models are not able to fulfill the need. You can build a custom model. For example, this is giving an image classification of the category or the class of an image. It can also, go through object detections, which classifies an object in an image, and return it also return a bounding box coordinate to locate each object. You can train a custom object detection model with your own images as well. And to summarize, computer vision, as we mentioned, is built on the analysis of manipulation of numerical pixel values of an image, and machine learning models are trained using a large volume of image to enable common computer vision scenarios. And such image classification includes object detection, automation, automated tagging, and optical character recognition, etc. While we can create your own machine learning model as well, but the most of the possible scenarios are being provided in the Azure AI Vision services, which is pre-trained capabilities, so that you can, use it to analyze images, including the OCR, object detection, classification, and other image processing tasks. So this is it from this side of this side of the video, and I'll be continuing this in the next video. We'll be going through all the facial recognition, optical character recognition, document intelligence, as well as other AI 900 requirement features, as well as the concepts related to that as well. So, if you have any feedback, just feel free to provide, and don't hesitate to comment your feedback. It will be really helpful for me. Thank you so much.